Yeah, and you can.
This class.
Yeah, I think we can just start right now. Welcome to CS6220. Hopefully you're in the right classroom. Yeah, I'll work with that. I'll work with you on that, Akila, after. I'll just send you a couple of Teams messages on how to get that. But yeah, so this is the introduction to data mining. And there's a sign-up sheet for those of you who haven't done it yet. Just go ahead and fill it out, and I'll just collect it at the end of the class. So I thought I'd get started with kind of an. Oh, so sorry, this is kind of maybe the wrong. Okay. Very strange. That's the wrong slide there. Technical detail. Look at this. I usually use Microsoft. So. Maybe I'll just use slides. Oh, thank you. Okay, sorry. Sorry about that. Okay. Yeah, so to start with, Sorry about all the technical difficulties. To start with, yeah, this is me. I'm Carl. I'm actually just a part-time lecturer here, but actually very interested in data mining. I work at Etsy right now. I'm the senior manager there, kind of heading up the computer vision team. But I had some experiences in other more larger companies like Google and national laboratories. I graduated from San Diego in 2008 and Berkeley in 2002. I think I have some hobbies here. This is my son. I don't know if anybody has any, but yeah, he's great. And there are, I really enjoy climbing and quite frankly, artwork. So these are things that I really enjoy painting. Kind of enough about me, just kind of want to get a quick sense of everybody here. How about you in terms of who you guys are? I guess maybe if I can kind of get a head count of who's an Align student right now. Okay, that's 6. And how many of you have come from industry? I think you've gone to a company or something and then decided to come back to school. Anybody here? Okay. And are most all of you, how about part-time, full-time students? Who's a part-time student here? Everybody's full-time, okay. And finally, I think your experience in machine learning. Maybe I think I can kind of get, how many has taken a class in machine learning in the past? Okay, great. Well, this gives me a kind of a good idea. I think the reason why I ask is I'd like to kind of tailor the syllabus. I've made around 6 or 7 lectures so far, and then I started realizing that maybe you can kind of calibrate to student capability and kind of just adjust ad hoc. So, you'll see in your first homework, it's, I don't know if it's too easy or too hard. We can try it out and see whether or not, I need to adjust or anything like that, okay? So kind of we can start with what is data mining. So what is data mining? Can anybody give me what data mining is? A definition of what data mining is. Does anybody know? Or anybody hazard to guess?
Find the pattern in the data set and try to see if it can be applied to real world business decision.
That's right. Yeah. So you have a bunch of data and you want to figure out, what you can learn from it. And I put here past, present, and future, where I think there's a lot of use cases, a lot of applications. And like you said, it's basically extracting information from large bodies of structured and unstructured data, potentially from a bunch of different places. And so if you have a lot of data, what you can do is you can take a look at, what happened in the past. There was a catastrophic event, or there's something that was problematic in the past. For example, in COVID reactions was fairly poor, maybe, for example, in New York City. What is the pattern? What are the patterns in the data that can lead you to a little bit more information about what actually happened there? What are the statistics that you see? Which hospitals might be overrun? Where do you need to allocate resources? Maybe the next time you have pandemic level problems. Present, these are kind of more real-time events, right? And so you talk about present and, sorry, let me just go ahead and move back here. So you talk about problems in the present. In fact, there are things like fraud detection. For example, if credit cards see suspicious activity. So how do they get the information about what is actually suspicious? This is kind of a field called anomaly detection. And a lot of that really is real-time data mining or data mining and then applying the analytics to real-time applications. And finally, future. I think this is actually very relevant to what I'm doing right now at Etsy, where we take a look at what we can recommend to people. And the way we recommend people in terms of listings and those types of things is to find out, what are the things that they've looked at in the past. So using data to be able to predict what recommendations to service. So again, it's extracting information from large bodies of structured and unstructured data, potentially disparate sources. And I think the prime example is Amazon. So, I mean, how many of you have Amazon Prime? Curious, okay. All right, yeah. So I don't know if you guys know this, but like obviously there's like a 2-day shipping thing, right? Have you ever thought about why they can do this in 2 days? Or have you ever thought about like there's even hourly shipping? Are they like within the certain single day? Have you ever thought about that? Does anybody hazard a guess like how they actually do it? So it's all supply chain logistics, really. But beyond the supply chain, right? You know, you have trucks sending things to places, or you have warehouses that have robots driving around, which is again, you know, parts of data mining, also machine learning, those types of things. But where they place the items, the products, not only where they place it, which warehouse they put it in, how many, for example, how many blouses do you have? Or if you have how many blouses, what colors or what types, those types of things, right? These are actually problems that data actually uniquely solves. And these are problems that Amazon, for whatever reason, or not for whatever reason, for monetary reasons, for financial reasons, have expended a lot of effort in terms of supply chain management with artificial intelligence, machine learning, and not the least of which data mining to understand the populations of locations and logistics and travel times from trucks to your doorstep. Right? So that's called the last mile on Amazon. They actually break up the logistics in terms of first mile, middle mile, and then the last mile, right? So the last mile is like, where can I get the stuff from to get to your doorstep? But the first mile is the actual recommendations. You know, what can we serve to you so you'll actually buy the product? So that's one example, Amazon's supply chain logistics. The second one, how many of you have heard of the Netflix Grand Challenge? How many of you know what the Netflix Challenge is? So Netflix, the challenge is actually, they sent out, I think it was in 2006. They had $1 million prize to be able to beat their existing algorithm on their recommendations. So they have, you know, users, and they had movies, right? And pairing these movie recommendations to which users would actually watch the movie, that was a challenge. And you know, I think there was a team that won. I forgot their name, but it was $1 million. And back 2006, that was quite. I mean, right now it's still a lot of money, but back then it was actually a lot of money too. And I think it just goes to show that I think there's a lot of effort expended in being able to use. I think they had a set of data that was quite extensive at that point in time, not nearly the amount it is today, but use that data for, I guess they call it like gross merchandising, right? So that's the Netflix challenge, and there are other domains. There are interesting domains for data mining. So I think there are, in this particular case, these are more like biological and biomedical, bioinformatics, healthcare, and pharmaceuticals. Bioinformatics is kind of this field. Actually, who can kind of give me what bioinformatics actually is? Does anybody know what bioinformatics is?
Like DNA.
Right. It's genomic analytics.
I mean, like you said, like genomatic, like information, like how they affect your appearance.
Right. It could be a variety of things, right? So you have genes in your bodies, and the way they actually get expressed, that's called a phenotype. But you know, even if you do have a phenotype, whether or not it's expressed, even to a lower level, you know, you have RNA transcription, protein transcriptions, basically creating new proteins. You know, these has a lot of implications, also specifically for, you know, who reacts to certain drugs, for example, or who reacts to viruses in certain ways. Because viruses, a lot of them are like, you know, treated with mRNA vaccines, right? So bioinformatics is a field of, you know, genomics, and, you know, I think people deal with this, I think, with problems to include things like cancer as well. There's also clinical data mining. I think like actually who can give me an example, like who can actually tell me like if you go to a doctor or if a lot of people go to a doctor, for example, what data could be used for in this particular case. Just the sky's the limit, I think, with data mining. Just generally, I think maybe if you guys can think of data mining in the clinical setting or the hospital setting or the doctor setting. Does anybody have any ideas?
Clinical trial.
Clinical trials is one to see whether or not a drug is, so actually that's actually pharmaceuticals, right? So drug trials, for example. But these are, for example, like patients, you're going to see a patient or doctors see a patient, for example. So the way that, I think, so there's a company called abridge.com. So I used to work in VC a long time ago, and there's several startup companies. And if you ask anybody, electronic medical records is kind of one of the messiest and problematic things here in the United States, just because a lot of people just don't share data for academic reasons. People publish papers, maybe they don't want to tell the other people about their data for whatever reason. Doctors write notes. Actually, teaching hospitals actually have been notorious for this, is that teaching hospitals have data and they don't necessarily share it. It's actually opened up in the last 10 years, but in the past, electronic medical records was actually a very difficult problem. So there's a company called abridge.com. I'm just plugging them just because I know them, and my friends have kind of been telling me, oh yeah, why don't you invest in them? But that's not advice, by the way. But the idea really is, hey, they're able to take doctor notes and then provide real analytics, like treatment plans for these people. Did they respond well to a lot of things? Because if you have a larger population, you're able to predict a lot better. And so again, here later in the slides, we'll get to it about how data actually affects compute and how compute actually is able to give a more complex and more difficult problems. And finally, the area of interest is pharmaceuticals, where I talked about drug trials and actually drug discovery. Complex molecular drug discovery right now is used by a lot of pharmaceuticals. It's a very heavy investment for a lot of pharmaceutical companies. How many people know of the conference NeurIPS or KDD or any of these machine learning conferences? Have you guys heard of NeurIPS, or used to call it NIPS? Is that NIPS? Yeah, they used to call it NIPS. They changed the name because of certain reasons. But yeah. Does people have heard of it? You've heard of it. So NeurIPS is actually, it used to be a neuroscience conference. It's really just turned into a machine learning data mining conference. And you'll see later in your project, actually, I've put a template for KDD or like these other conferences, so that if your project turns out to be interesting enough, one of the main things when I look as a hiring manager, I actually look at, how many publications do you have? But anyways, that's besides the point. I think I'm really digressing. I think the idea really is neuroscience has actually kind of been taken over, or not taken over, but it has a large component of computational neuroscience or cognitive science. And then subsequently, a lot of the applications, are very much data mining oriented. So more on that later. I think, perhaps like more of what you guys may be familiar with, social media. I think there's search, social media, and e-commerce. This is Twitter, Facebook Marketplace, but it has suggested recommendations. The way to suggest recommendations, how do you tell? Like, so for example, if I wanted to provide a recommendation to you on who your friends should be, how would I mine the data? What information would I need to be able to provide you with that recommendation? Does anybody hazard to guess? How about like who I know or who you know? How about the same posts that you follow? So this is the type of data that you'll be mining, I guess. Well, you won't be mining social media, or unless you want to choose that for your project. But that's the type of things that you'll be able to leverage or take advantage of in order to provide good recommendations for, I guess, for example, social media for people who are on Twitter, for example. There's e-marketplaces. How many people who knows what this is? This screenshot, it's a little bit small. It's Alibaba. Sorry, it's a little bit too small. That's one marketplace, e-marketplace. Again, I mentioned recommendation space. It's actually called Recommendation Sciences, which is actually one of my later lectures. So that's really based on, what have you bought in the past? Who is similar to you, for example, using a lot of the data that we've gathered in order to personalize your recommendations. And again, I'm at Etsy and I'm going to plug them here, but with the same idea, right? We're kind of more of a marketplace for sellers and buyers to kind of homemade their items. How many have heard of ChatGPT? Who knows about ChatGPT? Sounds like people have heard of that. How many have tried ChatGPT?
I have.
Have you?
Yeah.
What's your experiences with it? How does it work?
I tried a lot of tricks to trick it into saying things it's not supposed to say.
Yeah, so ChatGPT is kind of one of these interesting things. It takes a large corpus of data. So I think GPT-2 actually was terabytes of data. I mean, the number of parameters was kind of almost more than you can actually handle in terms of what compute can actually use in real time. But I mean, I'm sure none of us will be able to use, I think, the GPT-4 that is out there in terms of inferences. But ChatGPT, yeah, it's kind of an application. But take a step back, I think, there's other natural language processing approaches. How many have heard of BERT, I guess, as a natural language processing approach? Great. So BERT is another machine learning algorithm that is for natural language processing, creates embeddings, and we actually use it today. We use it also at Etsy. We have kind of these search recommendation modules, and we use it BERT embeddings to provide you recommendations of how your query, so you have to type in queries, right? Or try to understand the listings that people are trying to buy from. So BERT is one of those techniques that we use. We use other approaches, obviously, in natural language processing and obviously computer vision for that as well. And actually, quite honestly, I forget what social media site this one is. Can anybody tell me what that social media is? Yeah, okay, I think it is too. So that one's Weibo. Also, again, social media site. Okay, so now a little bit more technical stuff. Well, not technical stuff. We're still in the introduction. I think we'll get to more technical stuff a little bit later. But this is government science. I used to work at the National Ignition Facility. There's a lot of other national laboratories, Los Alamos National Laboratories. So particle acceleration they have reams and reams of data. Actually, if you look at, in the 1990s to the 2000s, no one actually had any high performance computing except for government funded science. And because of that, government funded science was heavily involved with a lot of where government investments in universities went. So DARPA is a government investment in, is a government funding agency. DARPA funded a lot of, including the internet, actually. So if any of you know about the internet, the history is they were DARPA funded a lot of the research that went into creating the internet. I think they still have a lot of compute. Particle acceleration is a big part of that. 3D manufacturing. Who knows what 3D manufacturing is? Or just manufacturing, just generally. Printing, 3D printing. A lot of the processes that you use, they could go wrong in a lot of different ways. You print things and then you have basically maybe a few thousand wafers that are just like useless, right? And if that's cost ineffective. And so they've been putting a lot of machine learning and artificial intelligence into 3D manufacturing. Imaging from airplanes, that's actually a pretty big thing. I'm not going to get too much into that. I'm sure there's probably some government applications you could think of where planes fly over things and take pictures. Seismic anomaly detection. Right now we live in California. There's a lot of seismic activity. There's actually remains to be seen whether or not there is a relationship to be had to be able to predict when the next earthquake will happen. But for now, let's try to throw data at it, throw algorithms at it, to see whether or not there is a pattern to do pattern recognition, machine learning on it. Climate change research, underwear, acoustic modeling, image apparatus. Who knows who this person is? Anybody know who that is? Her name is Katie Bowman. She was the first person who imaged a black hole, right? I think there's actually interesting imaging apparatus for satellite imagery. It took tons of data from basically around the world. So it turns out the world spins, your telescopes can kind of see out into space the same locations, just at different times. But in order to get a very, very high resolution farther and farther out, what you would really do is just basically wait until the telescope spun, the Earth spun, so that other telescopes can actually see further out. And in that case, in that particular situation, you'd be able to get higher resolutions of satellite imagery. So these are all kind of interesting applications. That's not all. Who's watched Moneyball? Does anybody watch Moneyball? Does anyone know? That's kind of maybe a long time ago, maybe. Brad Pitt? You guys know who Brad Pitt is, right? Okay. All right. Well, so Moneyball, again, is this idea of sabermetrics. Sabermetrics, the Oakland A's back, I forget what year, they weren't doing so hot. And instead of relying on scouts to pick and look at people say like, oh, I think this guy's good, he's got a good swing, or this pitcher is great, they are able to pitch it within, a few, whatever, like 100 miles per hour when we shoot it with a gun, a radar gun. But instead of relying on all of that, they're looking at on-base percentage. They're looking at strikeout rates. They're looking at all of this data and doing a lot of analytics to be able to do data mining on it to affect better a team, to recruit a better team. And as it turns out, they actually went to the championship. They lost, but they made it there. They were actually slated to lose because, quite honestly, who's going to trust data back then? But as they were quite successful, no one has been able to replicate that, in the recent years. But sports analytics, that's also because a lot of people jumped on it, and so there's a lot of competitive advantage that was lost. Obviously, computer vision applications, self-driving cars, political science, campaign management, and ad targeting. You see that a lot with Twitter right now, and cybersecurity. So yeah, these are just kind of things to name a few, and I really just want to maybe kind of ask everybody here, maybe what are some examples of data mining in your life? Hey, why did you decide to take this class? I guess maybe it's kind of a good question to ask. What do you think? What are some examples? Can anybody give me any examples of just what they could use data for, or what they have used data for in the past? Nobody? San Francisco? Anybody? What, recommendation engines? Yeah. Search recommendations, recommendation engines. That's actually my field right now, what I'm doing. So, anybody else? Oh, we'll punt on that, and then I think I'll be very excited to see your project ideas. I'm sure it takes a little while to marinate. Hopefully, like all these other applications right here, kind of inspired you. And we'll just kind of move on to that. So, I asked, why everybody chose to choose this class. Obviously, data mining is very interesting. I find it interesting. I think it's really great to learn. There's a lot of different professions. Perhaps that's kind of the ultimate reason, maybe, but that's okay. I think it's a very worthy cause to kind of work in this area. And so there's a lot of different types of positions. And honestly, I didn't make this slide. I got it from one of my fellow lecturers. Shout out to Everaldo, who lectures this in Seattle. But these are kind of just 5 different professions: business analyst, data engineer, data scientist, machine learning engineer. There's applied scientist, applied machine learning applied machine learning engineer is there. Let me see if there's anything else that I might be missing. I'm sure there's like a title that I'm missing or something there, but these are kind of like just 5 broad categories. I think the definitions for each of these is very murky, to be honest. And I think I'll kind of get into that. And I do kind of have some advice on this, but again, like this maybe isn't like kind of something we could focus on now. We could focus on at the end of the class, but I do know that a lot of people really kind of look at data mining and machine learning as kind of more of a financial investment for their career. What I will say is that like don't pay too much attention to the titles. You know, when I was at Google, there really wasn't a machine learning engineer title, right? That wasn't a ladder. A software engineer was the ladder. Software engineer with machine learning skills. Even the people that we collaborated with at DeepMind, they were also software engineers, right? And so the ladders at Google are kind of agnostic to the title. But what did matter was whether or not you passed the first round with your resume, whether or not you had those skills. The subsequent rounds interviews to test your engineering knowledge and ability, skills, and your depth of knowledge really matter the most. And you know, quite honest, we can get into that, you know, later. And I think I kind of have a lot of tips and tricks I typically tell people, you know, at the end of the lectures or you know, the courses or wherever. But here are some like less well-known places, data companies, Vectra, Scale, Turnitin, Canvas, DoorDash. So how many have heard of Vectra? I'm sure not too many, right? This is kind of from cybersecurity people, but everybody else, hopefully you guys are somewhat familiar with. Okay, good. Okay, so these are just some data companies. And I think, you know, with that, we're about half an hour in. I think maybe we can kind of go over course logistics. How does everybody feel? Maybe do you always want maybe a 5-minute break before just getting into our logistics and the meat? I'm probably not asking you out loud. Let's take about a 5-minute break and then come back. And then, you know, we can go through the course logistics. But that was just kind of a brief introduction, and you know, we can, if anybody has some questions about it or anything like that, they can come and talk to me during the 5-minute break. Sorry, go ahead.
The slides post somewhere so we can.
The slides posting?
Yeah.
I'll post them after the lecture.
Okay.
Okay.
Thank you.
Yeah. I'll be back in 6:40. Yeah.
Yeah, I mean, I also curious how to follow the slide.
Yeah, I'll post them. Yeah, I'll post them.
We just have a few questions.
Sure. I think it's just better experience here. So yeah, it's totally fine to do it. I don't know like what the implications are, but how do you just change chaos? Is there a way? That's fine. That's better. Yeah, I've been getting a lot of these questions. So what I'll do is I'll like kind of I'll need it from. I generally like would love to be able to support you, but I think it's actually there might be like issues with or anything like that. But oh, it's just in class, you know. It's kind of. When you're gonna get one, it's gonna be like and then it won't show you. It'll just be, I think, hopefully fairly straight. This is an elective class, so we'll get into what else is there, but it's an elective class. It should be.
因为我感觉这个小地方没有结束了是吧？我要 我就一直聊。
对
And when did
I think it's right before spring break.
哦，
Okay.
So in my
search 我让我写。
上次的时候吧，应该是
是在 search 里面的
search 下面的
回原的这还是
哦，对，
actually, you know,
哦，而且我觉得这边有点
刚进来的时候，我在一个
对
对，他就
yeah, actually, maybe I need to ask this to be sure. I mean, I would prefer the really? Okay.
有一个
Is everybody signed in? Go ahead and sign in.
Slide said.
Everybody's, I've been asked. I don't think it's I think this is from last time. This year. This is the first one. So, you know dynamics.
Yeah.
Okay, then.
Person, creativity and.
Yes, that's, I think, extends. Yeah, linear algebra is probably. Yeah, it's mostly fine. I think. Well, if you have a better, like. Java.
Yeah, but I can't say that.
It's actually. Because the Java is my first. I think I'm generally like language, like, to be honest.
Yes, also creating more, more technical express.
But you'll see, I think in after section 1, there's actually like a lot of your code, like quite honestly, you don't even know like math reduce or those other algorithms that we'll be learning about. They want
I'm very familiar with Java because all living code found them and also.
Oh, yeah.
I do use Java.
Oh,
But
okay.
Python, I it has.
Yeah. I would say like most data mining or machine learning interview questions, like interviewers, they typically use Python. I mean, I think like it might be a good, like this class might be a good practice to be able to.
Okay, thank you.
Okay, so we're about 2 minutes over. We can do the sign up sheet a little bit later. Please only sign in for yourself. I'm gonna do a head count just to make sure everything is. Okay, let's go ahead and start back again. So I had some pretty good questions. I hear. So one of the questions was like kind of a prerequisite of CS5800 versus CS7800. Quite honestly, like I think I don't necessarily believe that you need too much CS background generally for data mining. You do need a little bit of linear algebra, but I mean, your first homework, you'll see, I think the extent of the actual computer science programming techniques. You do need to know, like, you know, coding and a little bit of recursion and dynamic programming. If you can get past the first assignment, then really it's just kind of like everything else is very simple to do in terms of coding. So yeah, so anyway, that's kind of just one of the questions I've had. So CS5800 is sufficient. CS7800, if you have it, that's great. Otherwise, CS5800 should suffice. There's another question about Python versus the other languages. Most of the homeworks are in Python. You'll find that a lot of the machine learning interviews will be in Python. I think like just generally it'll be in Python. But if you want to run the different languages, let me know. We'll talk about it and we'll see like whether or not. But just generally, I think this class isn't about the language. It's about data mining, right? The techniques and the approaches. So again, maybe I should have gotten this first slide. But I'm Carl. It's nice to meet everybody. Our TA in San Francisco today is actually Akila. Thank you for filling in. But generally, it's Christine. I don't know if Christine is online right now. She can say hi. If not, it's okay. I can't really see who's here. And there's actually a little bit of a mix-up here in San Jose on the TA. Before it was someone from Boston. Right now, we really need to have someone on campus for the San Jose office. The TA would be able to do it. We'll work that out. And just generally, you'll see the lecture format is kind of very similar for most of the classes. You'll see some, this is actually the lecture format. You see two sections just generally. The first section is a brief introduction to the course. Sorry, for us, this course is brief introduction. The second section is kind of larger scale data pipelines. This is this class, but generally I'll follow that format of two sections. And then we'll talk about administrative things like your projects. Right? Okay. So that's that. And a lot of we talked about grading percentages. I think before I was advised to add class participation in here. Really, it's just going to class, kind of being involved, making sure that you're a little bit prepared for it. It just generally won't be very difficult. It won't be very difficult class. I won't try to single anybody out, but 5% of it is class participation. You'll see the sign-in sheet. It's just kind of just to keep people honest. 30% is homework. And then 40%, you'll see 10 and 30, 40% is your project. And finally, the 25% midterm exam, which right now is actually the week right before spring break. So in terms of communications and feedback, really, I think this is an elective course. Thank you for taking it. It's an elective course. What that really means is it's a little bit, in this particular case, it's broad and not necessarily going too deep into a lot of these techniques. I think a lot of it really is, I'm not going to try to make the homework too hard or I'll try to make it not too easy, but like I'll try to make it not too hard either. What I mean by that is essentially what I would like to have is kind of feedback on it. Like how long did it take you to do the homework? I don't want it to take like 40 hours or 30 hours or anything like that. And so what I'll do is, and I think there is some advice on how to do this, but in my case, what I'll do is I'll just randomly poll you guys weekly, maybe send you a Google form or something like that to see like, oh, okay, how long did it take you to do this homework? How clear was it? Is the material too easy or is it too hard? Am I going too slow or too fast? Pacing, clarity, and materials. So I think what I'll do is, after next week we'll talk about office hours, but next week I'll also pull people on homework. The resources are I kind of have a full textbook list right here. Textbooks aren't necessary. I think so much on the web, but the full list is kind of linked, and I'll send this link out to my presentation a little bit later. There's a free course at Stanford that's actually where the textbook comes from. It's called mmds.org. I'll send that out, and if I forget it, please do remind me. I think I have kind of a lot of priorities right now, and I would love to make sure that this is actually taken care of. Lectures again, 6 to 9:20. Thank you for showing up, obviously. And within the lectures, there's going to be a lab. So at the end of this section, so there's two sections. After this section, there's going to be a lab. After the next section, there's going to be another lab, but that lab is actually tailored towards your homework to make sure that you guys can do it. And for communications, Microsoft Teams. Again, this is my email address. You guys have it. A lot of you have emailed me already. My office hours right now is 8 to 9:30 on Tuesday. Actually, how does this work for people? Okay. Well, if it doesn't, send me an email, and I think I'm glad to try to accommodate. Maybe I'll take another poll to see whether or not it is okay. Tuesdays at 8. Maybe I'll make it Thursday if that's okay, or if people want Thursday instead, just right after the lecture. There'll be 2 TAs, Christine and someone in San Jose. I think what I'll do is Christine's probably going to do Tuesday because I'm sure there's like last minute homework questions. The San Jose person, maybe we'll kind of make it Thursday, 2 to 4 p.m. Does that sound good, or any concerns actually? I know this is hard to speak up, but if there are concerns, you can send me a message. But for now, if anybody wants to speak up, that's totally fine. Okay, so what homeworks are due Wednesdays at 5 p.m. The first one is really just kind of a calibration. Firstly, I'll get to the homework a little bit later. It's kind of an electronic submission via GitHub. There's 2 components to each homework or write-up. Essentially, that's probably what TAs will grade the most. And then subsequently, Python code. It can be either notebooks or, as you'll see a little bit later, collabs for this. And submission will be via the classroom GitHub link. Yeah. Okay. Okay. So yeah, and let's get to the course project. Actually, at the end of this lecture, we'll talk about the project. Again, the emphasis on write-up, code, and data. Emphasis on the components are the write-up, the code, and data. It's actually similar to your homeworks. But really, I think that's open-ended because I want to be able to make it actually fairly common to how it's done in the industry. Like, so when I want to have new proposals for a better recommendation system, what I would do is essentially say like, okay, spend a little bit of time of doing some research, go to some product managers to figure out like what are important problems to solve. And because of the important problem, like because my eyes just go out there and just go look at these, they find the most impactful problems, I think they have really good justifications, then they'll start writing a proposal. I kind of want to give you guys that experience of kind of more of an open-ended project to be able to do that. And so it's your decision on what project you decide to choose. And this is actually kind of replicated in Seattle as well. They do this type of approach. Graded as follows: clarity and justification. For any of you that might face any language problems or anything like that for any reason, this is kind of my obligatory pitch for global learning services. Global learning services that are available for you to be able to, write good reports. A lot of it is based on your approach and technique, but again, communicating the approach and technique is also very important as well. Replicability and results. I don't think we'll be going in there and like reproducing your data mining pipeline, but I think the most successful projects actually do that. And finally, there's actually going to be a presentation, so no final exam, right? Project will be presented in lieu of that, and then the project write-up will be submitted afterwards. So you can choose teams if you want to. If you don't want to, that's okay. Teams actually makes it easier for us to grade. So maximum 4, and I've been advised that to also have people tell what their contributions to the project were, just in case someone isn't pulling their weight. Right? But hopefully we all get along. I think there are some cases when that doesn't happen, but that's okay. I think let's move on to grading. This is actually like I straight up copied this from everybody else's website, right? So A minus B plus, and pretty much is kind of how it's been for probably, like you guys are very familiar with it. The weighting for it: class participation, midterm, homework assignments, project, and final project paper. So I'm going to calibrate your homeworks as necessary. So please do, I'll pull for feedback. Midterm exams, again, I actually had this question come up during the break. They're not going to be surprised that there should just be a rehashing of what I talk about in the lecture and what's in the homework. So if you've done the homework, if you've come to lecture, then you will be just fine, right? Okay. All right. So this is the syllabus, and it's actually very subject to change. I think I might be very ambitious, but today's the introduction. Maybe you'll learn something today, I hope so. But I think we'll start serious instruction. I mean, it'll hopefully lay some groundwork or framework. But serious instruction just generally every week. Data analysis and summarization is the next week. Pre-processing is the week after that. That's things like MapReduce. How many have heard of MapReduce here? Okay, so that's good. At least you'll learn something. New in week 3, frequent item sets and parameter estimation. Quite frankly, actually, I've had too much experience with frequent item sets in the industry, but it's actually I think it got a lot of good applications for problems that we can probably solve. Parameter estimation is kind of at the heart of most machine learning. So that's week 4. Unsupervised machine learning, supervised machine learning, we'll get into that a little bit later. And then, everybody's favorite topics, deep neural networks. It's all the rage right now. And then you'll have a midterm exam in week 8. Spring break is week 9. And then, I've actually only created lectures up to week 7, to be honest. Week 10 through week 15, I think we'll see how we do for weeks 1 through 7 to see whether or not we get through all the material. But there's a lot of, I think, a little bit more advanced topics. Actually, week 10 is probably more mandatory, but week 11 on, in terms of other forms of machine learning, things like reinforcement learning and those types of things, mining relational data, things like graph and analytics, and infinite streams. Recommendation sciences, my favorite topic. And then finally, week 14, industry day. I don't know who's looking for jobs or anything, but there's a lot of people that I was hoping to invite to come over and talk about their pipelines, and including some VCs, right? If anybody wants to do a startup company, it's up to you. But anyways, week 14 is that, and then we'll do some parting lecture advice for that, to the extent that you're willing to listen to me give advice. So the goals for this is, and I'm going to go through each one of these, each slide by slide, but get some practice for the libraries, get some practice with some toolings, understanding of some machine learning, be able to read like mostly all the papers on arXiv. Actually, how many people look at arXiv now? How many people look at those papers or read those? All right. Yeah, it's kind of where a lot of scientists get a lot of their algorithms. Really, I think we're at such the cutting edge of data mining and machine learning that if we actually don't apply something that's been published, we're actually a little bit behind. So from it used to be that publication to engineering took maybe 5-10 years. Now it's actually like yesterday. But anyways, there's that. And then know how to prepare for interviews. Quite honestly, a lot of these concepts that we'll be learning will hopefully help you in your interviews. Okay. So again, goals of this course, data mining. These are a lot of libraries. We're actually not going to do all of these libraries. We will work with TensorFlow and a lot of these things. Does everybody know NumPy? People know NumPy? Okay, hopefully, yeah. These are just kind of machine learning frameworks. So, you'll be using a lot of that. And goals for this course, for data mining practice in terms of tooling, these are just large-scale data tooling toolings based on distributed data. Is this actually familiar to anybody here? For example, who knows about Hadoop? Who knows what that is? It's just a way to stripe all of your data over a ton of servers. Who's heard of Spark? All right, so we're going to be working with Spark in this class. And quite frankly, I had to relearn it when I was preparing for this class. And it's not too bad, actually. So it's pretty good. So Spark is something that we can learn.
Are we going to so for those skill set, are we going to start from scratch, or we're going to use well-established software and platforms?
I think it depends on what we're trying to learn, but we'll probably mostly do well-established libraries, right? But when it comes down to parameter estimate, so we'll get into it.
I mean, for example, with Spark, are we going to use the well-established that are used in industry. Oh, we're going to use the Spark or Hadoop using the terminal.
No, yeah. So we'll get to that later, but I think there's a collab actually environment that you can use Spark and that some industries actually use. Some companies that actually we use Spark actually at Etsy. So yes, the answer is we'll be using existing tooling. Yeah. That's a good question. Machine learning. So I know some of you have taken machine learning. Hopefully it'll be a breeze for you. There's actually a lot of different philosophies around how to learn machine learning. If you ask Andrew Ng, like using established libraries is great, providing course material. Actually, who knows and watched Andrew Ng before? Who knows who Andrew Ng is? Okay, so he's kind of the founder of Coursera. Well, now he's kind of stepped on and moved on to do other things, like deep learning.ai. There's other leaders in this world. I mean, I think this is kind of like machine learning superstars. Andrew Ng is one of them. Fei-Fei Li is another person. Who knows Fei-Fei Li? Professor at Stanford. Yeah, Google person to director as well. I mean, I'm sure she's everywhere. So, okay. So anyways, there's different philosophies on how to learn machine learning, right? Machine learning can be learned from, oh, okay, I want to use libraries to do this. I want to use Keras and just basically stack layers together. This is great. There's other people who will say like, oh, you only need to use the cost function. You only need to learn the cost function, okay? Which is, the cost function is an objective. When you specify machine learning algorithm, you specify an objective. There's people that say you should learn how to do everything by hand and be able to calculate a deep neural network that will be able to do it, and then you'll know it inside and out. I kind of fall in between. I think a lot of these things, these people, these philosophies, and you'll see a little bit later, I think it's actually kind of worth understanding how some of these algorithms work to a deeper level. Because one of the things that I know in industry that is kind of very commonly I see it time and again that some of my reports just don't necessarily, able to do this. But specifying a cost function or specifying mathematically what it is that you're trying to do, it's actually somewhat of a skill that some people don't have in industry. And so I think in this particular course, and it's actually important. I mean, I think it affects our gross merchandising, the finances that we have. So in this course, we'll be able to specify that, and hopefully it'll help you in your future work. All right. So on with goals of this course. So data mining in practice for recent scientific advancement. So reading papers. So if you're not learning it here, can you learn it somewhere else? Can you learn it with papers? So not necessarily, I'm not going to teach you everything, obviously, or you're not going to learn everything from other professors. You're probably going to need to learn it from archive. You're going to probably need to learn it from papers out in the wild. And so I think hopefully by the end of this course, you'll be able to read 80 or 90% of those papers. And finally, to make sure that you're well prepared for the interview, everybody does leak code, right? I think, unbeknownst to you, I've done a lot of interviews and I've failed a lot of interviews. I'm not afraid to say that that's actually fairly common. But when I did fail the interviews, I took note of what was problematic, like what I didn't know. And so I think here's some of the things that I think you'll hopefully learn by the end of this is kind of agent decision theory. How do you make a choice? How does an algorithm make a decision on some data? Deep learning, how does it really work? I mean, some of the interview questions are based on convolutional neural networks and understanding how that actually works. And basically being able to speak to large-scale data processing paradigms and data exploration and understanding. I think these are kind of things that I hope that it'll help you in the interview, just getting you past that first mile. And then hopefully when you're past that first mile, you're able to perform when you're at the new company. So that's kind of the interview side of things. And again, this is kind of a summary of all of that. But if anybody has any questions, we can talk more about that. I think, oh, actually, where can you read more? Again, where actually surprisingly, I get a lot of this from Twitter, like a lot of like ChatGPT, for example. I got that from Twitter, like with diffusion models. That's something where AI makes up new videos or new images or whatever. I got that from social media blogs. Those are just like easier to digest online resources. And then news aggregation, and finally archives and conferences. You know, by the end of this course, I'm hoping that I hope I did wishful thinking. I put a KDE template into everybody's project folder or the project repository. That's a conference. It's actually a pretty well-known conference. So you know, if your project so happens to be very interesting again, you know, I would love to be able to help and advise on getting it in. So anyways, those are all the places that you can read more. And really, I think we can kind of move on to our first section, a brief introduction to the course. And so it's been about half an hour again. But before I go on, I think maybe we could take a break, but another 5-minute break. But does anybody have any questions with all of that material? I mean, I think I went through it pretty in depth, but yeah. Okay. If you have questions, I know like speaking up for like specifically like, oh, you know, how many percentage and so on, or my grade, is this my grade? You know, that's pretty scary. Always send me a message. Let's meet back at 7:10. All right. Where's the sign-in sheet? Okay, great. Oh, you have the sign-in sheet? Okay, great. Is everybody signed in? Or? Yeah, okay.
这个那个论文编辑的一个，也或者写 PDF 的，还有没有把？
没被虐过。
我知道，我这个报菜，所以就是。
难不去这样说，我把这完全都写了一个。经过他状态的洗，
很痛苦。
有关都被那个。
比较一下，比较一下。然后我连完之后发那个资料，知道。
我们是一个40个小时过来的人，为什么？
而且还有上过500课的那种，搞那课是干什么？那个啥也没干。这全是白交了。我没报的。50的啥都没有干。都说那节课了，就是事情比较少。被约束的还挺多。为什么播报？当时应该是就是准时选的课嘛，早上7点，然后我点进去以后已经为在死了。
真的吗？我觉得
你是上学期的？
那不知道。
这学期吧排着，我还给对收尾上午1点。上学期哦。我还没有，我上了。哦。这学期。哎，有没有想起想大家看下个阶段。哦。看到标题有人想出来一起玩。对吧？对，我上过照，对，你当时谁问？是加拿大的一个
710。
对，就每周后端标都是 JS 吧，然后前端就是 JS 啊，就是。
So any questions on, I think, on the last, so far we're going to get into a little bit of the meat right now. It's kind of just a brief introduction to the course. And I think I think some of you might notice it, know some of this, but it's good to refresh your memory on some of the more simpler tasks. But if I'm going too slow, please do let me know, I think, in feedback. So I'm happy to kind of speed up or slow down whenever we need to. So I think, coming into this class, data mining is really something that it's just a lot of people have different definitions for what it actually means. But really, I think if you take a look at where this is machine learning intersected with computer science theory, intersected with database systems. Right? That's kind of where it sits. It's hopefully this amalgam of all of these different types of algorithms. And really, I think these are the disciplines. I mean, I'm not sure. So all of you are in the computer science curricula, but there's other types of problems that other types of disciplines that you'll draw from. Presumably, you've taken some amount of linear algebra. I think business knowledge that will come. I mean, I think we'll talk a little bit more about that later in this lecture. But I think kind of just where it sits in the middle of everything is kind of like, these are the skills that you'll probably need, when you call yourself a data mining scientist. And then again, we talked about what data mining was. It's extracting knowledge from large bodies of data, right? And that's kind of what it comes down to. Who knows what ImageNet is? Who's ever heard of what ImageNet is? Okay, yeah. So ImageNet was this competition in 2012, right? And in 2012, people have been using tree model. Like, so for those of you in machine learning who've taken machine learning in the past, people have been using these old machine learning algorithms like decision trees, or just like decision forests, for example. I think a lot of it, and gradient boosting and those types of things. So back in the day, when people were doing a lot of these things, they were getting, certain performance on this competition. This competition is called ImageNet. So all of you can look it up online. You'll see, I think the first result that comes up is this competition called ILSRV, the ImageNet large scale, some retrieval challenge or something like that. And really what it is essentially like, hey, we have 1 million images. Go ahead and train your algorithms on it and see if you can tell us which of these 1,000 classes is this image. And people are doing all right on it. But as it turns out, in 2012, Alex Krzyzewski, he's one of the scientists back then. He's still a scientist now, but he came with the idea of using GPUs to be able to do this with deep neural networks. One of the simplest machine learning, it's not simple, but like one of the machine learning algorithms that I think in the past have been somewhat proven, but people kind of just stopped using it because there's a lot of computation for it. But you use GPUs to do that. So with this combination of ImageNet, with basically a whole bunch of data, 1 million images with 1 million labels, with the vocabulary labels being 1,000, basically you can choose one of 1,000 things, cat, dog, chair, whatever. Of that 1,000 things, how well can your algorithms do, right? And using GPUs and using deep neural networks, or neural networks at that time, what they called it, it was able to, I think, blow everybody else out of the water. 10%, 10-15% gain, right? When you talk about 10-15% gain in the machine learning world, that's actually quite, like, usually the incremental progress is like 0.5%. In fact, right now on ImageNet, if you actually even compete in it anymore, there's competition's kind of deprecated because it's been solved almost. But if you were to compete in it, actually towards the end of the competitions, you're going to get like 0.001 or 0.02% gain in terms of your performance. And that was enough, and that was actually quite a lot. And it is quite a lot now. But it was enough, or 2 or 3%, I think, from ImageNet was kind of the growth curve. It was kind of this, I forget what curve, which is your curve to reach the top. But yeah, I mean, that curve actually recently, and the reason why deep learning has excelled to such a point where is it's gotten to the point where the machine has now outperformed human labelers, right? Human people who say, hey, let's take a look at this image. What's in this image? And humans would say, okay, I don't know, it's a cat. I don't know, it's a dog or something like that. And the machine beats them out. So it's kind of, if you go to any of the NVIDIA talks with Jensen, he's quite the salesman. Jensen is NVIDIA's CEO. He would just basically say, oh, superhuman performance, deep neural networks, machine learning now, right? So for those of you who are actually kind of interested in this field, it's got quite an interesting history. But anyways, I kind of digress. I think for this particular course, the data is actually important. And right now, in this day and age, we have both data and compute. We're able to do both. And in this course, we'll learn to mine different types of data. There's text data, image data, text and image data, heterogeneous data, relational data, time series, infinite streams, structured and labeled data. And we'll learn to use different models of computation. So I think right now people typically use a single machine, right? That's very common. But there's other paradigms that are able to take the computation to a distributed server. basically I have my algorithm, but now I'm going to distribute it over a bunch of different servers, right? That's MapReduce. There's batch processing, which is how deep learning works. And then there's streaming and online algorithms. So there's different compute paradigms. It's just all very interesting. And we're going to learn to do this at scale, right? Again, distributed computing is one way to do it. And these are all the different techniques. And the lecture 2 will be distributed computing and storage. Lecture 2 and 3, the MapReduce paradigm, the batch processing, lectures 7 and 8, streaming and machine learning algorithms. That's actually kind of an advanced topic. So, you know, we'll see, we'll see if we get around to it. But I think I'm tentatively saying lecture 10 right now. Okay. Okay. So the data mining pipeline. Actually, before I do this, I think before we get to that slide, actually, maybe if I have a bunch of data, right? What's the first thing I'm going to do in a data pipeline?
Clean it, collect it, and then clean it, store it.
Pre-processing, yeah, exactly. Yeah. Anybody, after you clean it, what do?
Store it.
Okay, let me see if you got it right. Yeah, so data. So first you actually, that's a good idea. So you clean it, do some data understanding, you do data pre-processing, just like you said, you pre-process it. And then that's when you can actually get into the data modeling side of things. And then validation and interpretation, you want to see how well you're actually doing. And then finally getting some insights from it, making a decision from your data. Right? And so here are the course topics. These are kind of things that we'll go through for most of the class. In this lecture, I'll try to go over the basics of all of these, maybe lay some framework or foundation for you to be able to learn it. What is a feature? What is a label? You know, those are kind of the topics that perhaps some of you with machine learning know, but I think the rest of us, would benefit from some foundation before we start jumping into the lectures on those topics. The first half of the course, pipelines, techniques, and approaches, right? So I said I've only made 7 lectures right now. The latter half of the course, advanced topics that have evolved. So I mentioned streaming, machine learning, recommendation sciences. These are topics that I think maybe, I think I could put even out to a poll if, you know, time is going to get short on the types of things that we'll learn. So yeah, I think this is kind of just the overview of all the things that I'm hoping that we'll learn. Right. And so I think kind of getting into it in the first, business logic, right? So, and I put all of these icons up in the upper right-hand corner just to give you a little bit of a roadmap of where we are in the topics that we'll be learning. Okay. So the first is business logic, right? So say Etsy's CEO comes to me and says, I want to optimize for the number of users that come to our site. They call it DAU, call it MAU. They actually do this for Google as well. Google search is kind of one of these things that is dependent on growth. The number of people that come to Google's site. Etsy is actually very dependent on gross merchandising sales, right? So this is something that the CEO says, oh, I want to have more people come. But he's not going to know like what are the experimental objectives for us as scientists. So what we'll probably do is kind of just look at key performance indicators for the team. Key performance indicators for the team, right? And each team, each squad, or each initiative, for example, Google search, and more specifically, my group was proactive search, which is on the phone, you click on the thing and then it gives you, click on the search bar, it gives you a bunch of recommendations. What are the actual revisit rates for those particular users, for example? These are things that you could actually measure online, right? And then finally, like, okay, well, we can measure it online. I can't really necessarily, I'm not like coding up while everybody's clicking on things, right? So what I do need to do is train algorithms offline. And those are things that we can't measure. And those are things we can optimize for. Those are like objectives. Those are things called objective functions. When I specify an objective function, I'm specifying what it is that I want these algorithms to do, right? And so objective functions can have a lot of different components. And we'll get into that when we get to the machine learning side of data mining. So I'm going to go ahead and try this. So what's in data? So what's in data? So data, let's say we have a bunch of data, and let's say we have servers of data, and each is a bit. So a single sample of data. So like I say, so what's an example of data that I could possibly have? I'm drawing a blank. What kind of data do we have? Can anybody think of? Just throw something out there and I'll try to work with it. One of the examples later is like, I want to maybe say bicycle brands, for example. Okay, so say I have a whole bunch of bicycles that I want to figure out. Like, say actually this happened a lot. My bike got stolen at Berkeley for like 7 or 8 times. Not 7 or 8 times, it got stolen a lot. Actually, if you go to Berkeley, you ride a bike and you don't lock it for maybe 5 seconds, your bike will get stolen. Anyway, so let's just say like I'm BPD, Berkeley Police Department. I've reclaimed a ton of bikes. So this is actually something to do. If you go up there on a Sunday, on a certain time of the month, they'll like say, hey, here's all the stuff that people didn't reclaim that got stolen the past month. But a lot of the times, for example, brands are kind of filed off, for example. So let's say we have a bunch of bikes, samples of bikes. So these are data samples in here. Let's just call these data samples and data records. Striped over a bunch of disks of bikes. And, let's say in these particular cases, each one of these is called what? An instance, right? So this is an instance. This is an instance. Okay. But this whole entire set of data is called the population. Now, if I want to do batch processing, if I want to do machine learning or whatever, I would do it with a batch of data. And so a smaller set of data would be batch. So I mentioned that we want to predict the brand of the bike, for example. What is that called? What's the brand called? Like, what is it? What is it that what is the brand? What's that called in terms of data machine learning? I mean, it's on here, but I think I'd like someone to say, yeah, it's a label, right? It's what we want to learn, right? So each instance has a label. Yeah. And then the vocabulary is basically the set of all the unique values that features and labels, let's just say and labels, take on. So in this particular case, labels are like puffy or Schwinn or I don't know. They else knows bikes or anything. Well, anyways, those are the types of labels. So labels, for example, are puffy. These are just brands of bikes. Features, they can be homogeneous and heterogeneous. So in this particular case, what our features are actually, if you don't know, it's okay. We're going to go into it in a bit. But can anybody give me an example of what features would be? Like what?
Type of brake.
Types of brakes, disc brakes, types of brakes. Color, that's right.
Use some with the trial bike, with the bike, mountain bike.
Road. Trial. Oh, wow.
Okay.
Do you bike?
Yeah,
No.
the mountain bike.
No. Trick bikes. Anybody does tricks? No. Okay. So just like what I said, features are attributes used to train a machine learning system. they are properties of things that you're trying to learn. In this orange, these are features of the color, like said, and the weight, for example. That's an example of an observable feature. And if you consider fruit, features of fruit might be weighted in color. Two features would mean there are two dimensions of the feature. Two-dimensional system, if you want to do classification, in this particular case, it looks like a three-way classification. Again, this isn't on my slide, so I don't really know what those points represent. I don't know that there are too many different types of oranges, but I think in this particular case, it says apples, oranges, and something else. But yeah, if you want to draw a dividing line, which would be your classifier, which is saying that everything above this line that has a certain color of this and weight, that would be apples, for example, or oranges, I guess, in this particular case, because it is colored orange, and everything under it. That's called a decision hyperplane. It's called a decision plane that you'll actually use to make a decision. So everything above a line, they call it a hyperplane. And everything above that hyperplane is one thing, and everything below it is another thing. There's going to be multiple hyperplanes. I think if you're doing multi-class classification, right? And I think that's kind of one of the things that I will say, in terms of experience, is actually one of the most important. The most important things that you can do is choose the right features. Choosing the most useful input features can have a big impact on the quality. Some features may not be useful enough to separate the data. So, when I was at Google, just another anecdote. I don't want to get too much into it. I think we might be running a little bit low on time. But when we was at Google, the biggest part of my job was getting data from one place to another, right? We had things called proto-buffers, right? Proto-buffers is just a format of data. Changing the proto-buffer into this other format, moving it to somewhere else. I think that composed of 90% of my time. And then the machine learning side of things, I was like, oh, okay, well, I get to do it sometimes. But most of the time, it was a very simple machine learning algorithm. Most of the work was getting the right data. So anyways, I just wanted to belabor that point. It is kind of worth mentioning that like most of my experience is essentially the engineering side of things that kind of is one of the more important things. So again, a feature is an instance described by a set of features. An instance is described by a set of features. A feature is a property or characteristic of an instance. It can take on a lot of different value. It can be categorical or numeric. It can be discrete or continuous. Do you guys know what I mean by discrete and continuous?
Yes.
The discrete is like 0, 1, 2, or it's basically countable numbers. Continuous is it's kind of on the real number line, right? So, and then you would use those features, pass it into machine learning algorithm. You know the labels. For example, if it's a supervised machine learning algorithm, for example, it's a Huffy or it's a Schwinn, for example. If with a byte classification algorithm, you take the training features, pass it into your machine learning algorithm, you get predicted labels. So I think tossing it out to the class, what could be features in, for example, sets of documents? I have a bunch of documents. For example, I think, let's say I've got a document for all of the listings, a set of documents of all the listings on Craigslist. Does anybody know what Craigslist is here? Okay, so there, Craigslist, all these listings. What are some features of that? Words, obviously, right? Like you can use the words, right? Bag of words. What else? How about how many words? Are there pictures in this post? When was it posted? These are all good features that you could use. And in fact, if you talk to law enforcement, they are used right now, actually, because they do need to kind of script some of this data to see if there's illicit activity on Craigslist. So again, there's discrete features. Again, it's enough information to separate one object from another. I think typically machine learning algorithms, and again, these aren't necessarily like set in stone, but you can use a thumb rule if you can count with your fingers, maybe even on one hand, you should actually use those. in terms of a numerical value, so 0, 1, 2, 3, 4, 5. Beyond that, you might want to use a different representation. So if I have a feature x, xi, 0, 1, 2, 3, 4, 5 might be okay. But probably what you might want to do is use zeros and ones. So basically represent those numerical values as like a 0 if it's 1, a 0 or 1 if it's a 0, or 0 or 1. So it's probably better if I draw it. So in the case of 0, a set of 1, 0, 1, 2, 3, 4, 5, you would have a vector of 6 features, right? In this particular case, each of which would be either 0 or 1, depending on whether or not that particular value is there. So that's called one-hot encoding, and that's typically how a lot of deep learning machine learning algorithms have it work. Continuous features, most numerical properties hold. It's a real number. Things like temperature, height, weight, age, practically real values can be measured and represented as finite digits. I won't ask that. I'll just move on. And again, we're talking about bikes in this particular case. So moving on to, if you look at the icon, this is preprocessing and normalization. So first of all, what is normalization?
It's stretch the data into a fair interval.
Yeah.
Without like many layers.
Right. Yeah, outliers. Right. So I mean, I think it basically is like, hey, I have a tire size. So when you're talking about bikes, just that's kind of the example I could think of because I didn't give any other examples. But tire size 24, 26, 28 inches. You know, that's a pretty large number, but the tire width is very small. The paint values can go from 0 to 255 in terms of the colors that you could take on. That's actually a typical representation of images. You download an image, values the representation 0 to 255. Types of brakes, that's actually a discrete value, 0 or 1, right? So what will we do? I think in terms of stretching these out, just kind of make it towards, basically move it towards kind of a zero mean or something that is kind of more, like it treats all of these features fairly, I guess, right? So if you want to weigh something more than another, then you maybe make that range larger. But generally, you kind of want to treat these fairly, kind of the same among all of the other features. And so, in this particular case, that's you just basically normalize it. Can you really tell me why that's necessary for machine learning algorithms or just any algorithm? Why is it necessary for us to normalize features? I think it's just like what I was saying, is that you want to make sure that you're treating these guys in the right way, making sure that you're not weighing one thing over the other. Estimating parameters for normalization. So, how do I know what the mean is? Like you said, there's going to be outliers, right? Feature transformations, dimensionality, and noise reduction. Does anybody know what dimensionality reduction means?
For example, if you want to show a data set on a 2D axis, only X and Y axis, you have to use the noise dimension reduction.
Yeah.
To get more features into only 2 dimensions.
Right. So the idea is to reduce the number of dimensions that I have here, there's not too many here. There's only 4 or 5. I don't know. There's a lot of features here. Or not a lot, but imagine that there are a lot. So the idea behind dimensionality reduction is not all of them are actually relevant. Some of them might even be correlated. For example, tire size, and tire width, they're obviously correlated, right? The larger or bigger your tires are, and probably the wider they are, the wider they're going to be. And so you don't necessarily need all of the dimensions. It's basically reducing those dimensions so that you have kind of useful data. And then we have machine learning algorithms. It's kind of a branch of computer science that attempts to understand and learn from data. Machine learning is different from, I mean, it's kind of this big topic of machine learning. There's, within machine learning, how many have heard of neural networks? Most of you. If not, that's okay. We'll go over what they actually are. How many know what the difference between neural networks and deep learning is?
I don't know what exactly happened within the neural network box.
Right.
Yeah, it's more like a black box. Machine learning, you know exactly how the algorithm like capture the data, but in neural networks, you don't necessarily know.
Yeah, there's this element of explainability, I think. So I think we'll get into what neural networks, I think, like the explainability and like how you actually intuit what it's actually doing and why it's doing. Like, I think that's a big problem with neural networks. But it's suffice to say, deep learning is essentially, the neural networks, I think, it's kind of a model of machine learning that's modeled on how your brain works. Okay? And then deep learning is just a really complicated neural network. And so there's really not too much like vocabulary that really is too tricky. It's just deep learning is just a bunch more neurons or just a bigger neural network, right? Supervised versus semi-supervised versus self-supervised. I mean, all those different types of learning, reinforcement learning. I think we're actually going to get into like what those actually mean. So unsupervised learning, essentially, there are no labels for the human to, there are no labels to learn from. It's just a pile of data. I don't know what's in this data. So basically, given a set of data, I'll develop a model and a representation of that data so that important structural irregularities are captured. I think this is really, I think, just all of it saying the same thing. But you kind of really need to model what your data is actually doing, so then you actually do something with that data. And then you use this model to predict new samples of data. So basically, yeah, I said piles of data. So in the bicycle, or apples and oranges, color and whatever, and if no one bothered just to tell me what it was beforehand, basically I just have these things that I know are certain colors and certain weights, right? And a machine learning paradigm must learn from unlabeled data. And if we have these three clumps that represent three different things, the program must learn that there are three distinct clumps. And it's actually a very difficult problem. This is something that is not necessarily easy to do. Even predicting that there are three clumps is kind of arguable whether or not that's a solved problem. But again, we'll talk more about that. Association rules, that's just kind of another unsupervised thing. People say you have a basket of things. Like say you go to a grocery store and like you want to figure out like what things to recommend to people, and all you have is a bunch of like people's checkout receipts. That's kind of the quintessential association rules problem. Let's call it a market basket problem. So again, this is kind of what it is, and there's a quintessential example for it. I'll get into it in lecture 4, I believe. But this is kind of another unsupervised machine learning approach. So if that's that's unsupervised approaches. What is supervised approaches? If you have the labels, right? So the data has the labels and thus can be represented by tuples, X and Y, mapping from one domain to another. So you have your input features and then your classes, your labels. That's supervised learning. And so in this case, these are cars. This is not my slide deck. Slide from Silverado again, so I'm not too sure like these numbers are accurate. I'm sure they are, but anyways, these are like 3 instances with 4 features each with a label of what type of car it is. So given a car, make, cylinder, length, and weight, try to figure out what the body style is. That's one supervised machine learning algorithm. And then again, here's, if I want to, like, what's the weather like outside? And then, what am I going to do? So, again, here's 4 instances of which you have two features, and the decision is whether or not you go out or go. So again, in mathematical form, data is in the form of tuples of input-output pairs that comes from a deterministic mapping of your features, X. I use the letter capital X because that is kind of the full domain of all the features. So you're mapping from this domain of X to Y, to your labels, for all of your data points that you have labels for. And again, your X's can be X1 to Xn. And your features, again, can be N features. And Y is kind of a set of classes and concepts. So again, and you can develop approximation to mapping that's consistent with the data, but not too complex. Right? There's other types of machine learning algorithms. So anomaly detection, who can tell me what anomaly detection is? Anybody know what the definition of anomaly detection is? It's essentially finding things that are irregular from a probability distribution that you have determined a priori. Basically, I have figured out that the data typically looks like this. This kind of looks different than that. And in this particular case, there's a few applications: network intrusion problems, control systems monitoring, law enforcement. I mentioned Craigslist, right? Like, is there something weird happening with this particular listing? Graph data learning. This is the social network problem. Which person am I going to recommend? Whose posts am I going to recommend to you? And then there's self-supervision. Can anybody tell me what self-supervision is? Okay, so self-supervision is essentially, I'm not giving you labels, but maybe the label is kind of in the data itself. So I'm going to use parts of the label to predict other parts of the label. Right? That's called self-supervision. And actually, a lot of natural language processing does this today. Finally, reinforcement learning. Who knows about reinforcement learning? Who has heard of reinforcement learning? Who's heard of AlphaGo? Okay. AlphaGo is done with reinforcement learning, deep Q learning, deep reinforcement learning. Who's heard of StarCraft? The video game. Does anybody know StarCraft? Yeah, you play. Have you played it? Okay. Yeah. So Alpha Star, that is DeepMind's StarCraft game player. You can read about it. It's actually pretty interesting. It beat pretty much everybody. Actually, I didn't know this, but a lot of the best StarCraft players are from Korea, and so I think they got a lot of these best players in the world to play against StarCraft. They actually, AlphaStar did cheat a little bit in that it was able to see the entire map. That's okay. It still beat everybody, and I think it's quite interesting. So that's reinforcement learning. So those are the types of machine learning algorithms. Evaluation and visualization, that's we're over there in terms of where we are in terms of this section. There's a lot of different evaluation metrics that you can use. These are common ROC curves. We're going to go over this in lecture 8, I believe. Misses, precision recall, receiver operating characteristics. Don't worry if you don't know them now. These are important things that we'll probably learn later. Quite frankly, you're going to get a lot of interview questions on precision recall. So that's going to be one of the lectures as well. That's not the reason why there's a lecture, but it is an important lecture. Again, we talked about dimensionality reduction. That's going to be something that you can use for visualization and communicating your results. And here's some advanced topics again. We'll get to that when we can. And finally, now consider this. An advertising group, a company, wants to group customers. Now don't look at this, I guess this is the answer, but there are no predefined labels for this group. Based on the groups, on demographics and past buying behavior, they will have targeted marketing and advertising initiatives. So what is this? What type of problem is this? People read it. This is unsupervised learning. could be self-supervised if you have labels inside the data, but I think this problem specifies that there are no predefined labels. So it could be, I think the idea is to find similarities in the data based on the feature and then really clustering your data. Right? So again, I think kind of to close off this section, I know it's 7:45, getting to 2/3 of the hour. Thanks for bearing with me. The review before the break kind of gave you an overview of what data mining is. We talked that data and compute, most important parts, those things have progressed in the last 10 years to be almost exponential in growth in terms of algorithms and time from paper to implementation and engineering. Data vocabulary, like give you an idea of what an instance is, what features are, what labels are, and then introduce you to the different types of learning. And then finally, the evaluation algorithms. Okay. And so that's good. So I think that what I'll do right now is kind of give people a break. I'll start you guys on a collab. I want to get you kind of, throughout this course, there's going to be a lot of collabs. And I will do my best to give you the lecture slides before the lectures. Sometimes actually changing the lecture slides right before, actually I did that today, changing the lecture slides before giving the lecture, but I'll do my best to give that out to you and give you the link for it. And so then you can kind of click on these links to the collabs. For now, let's go ahead and start doing. How many actually are familiar with collabs, Google collabs? Has anybody used these before? You've used it before? Okay, great. Anybody else? Okay, a few of you. Okay, great. So for those of you who haven't, this is actually a pretty good exercise. This is just introducing you to Google Colab. It's Colab 1.1 because it's the first one, but this is introducing you to collabs and like how you can use it. For those of you who use Python, it's kind of exactly the same as Jupyter Notebooks, except there are really interesting magics. And so let's just go ahead and do this lab for about like maybe half an hour, and then we'll go on through the rest of the lecture, and the rest of the lecture will be kind of a little bit more of an interesting use case. Okay, guys? So maybe take a break before while I send this out in Teams. I'm going to send this out in Teams to everybody in the general channel, the link. And then why don't you go ahead and get started on this, and then probably around 8:20, I'll start lecturing back again. Okay.
I'll record that. How do you know what's channel?
这样可以满足。
没有的东西。
Actually, there's 7 of you and there are only 6 names.
I didn't know. I didn't choose this code. I just want to see. I still see the list, so.
Okay. Okay.
对吧？
电脑。哦。也说吧。我还没知道呢。
我们可以看看。
他心思好，因为你们没有点，说他是那个水沟的。没有个原因，是这个来，他这个我考上做的，我到我费老师，都好像这样做的，上摸不了一样，然后可能更硬的，还是我上来看吧，他们没有上，是的，我到为什么没法上？他们这里。
我被他压怕了，就是我们觉得我们做到极致的作业，被他压的，都就在几个那个分数的及格的边缘，我都看怎么给成这样，而且因为没有 TA 的参与，就是纯他给的，谁高？我们两个高还是 TA 高什么呀？对对是他把自己评。对，他有想法是他给了多少？没有问题，并没有。就是本来指望的情况。对的。辛苦的一天，所以他的起码而且 network。我看不了一点，但是我另外我没有办法那么上现在不要再看那两个大招了，这个好。
对啊，可以去报名兵马赛。
那个最空的。
8:20。我还蛮想去换车。
那样都对吧？
是，正好这前就对。
晚上
对啊，这是
灯量也比较少。
我上这个，
也是跟本科。
每次他们就没有
这个。很帅，
我要一首，这个他们大概有上去。正常的他们在144号线点上去，蛮好的这个园区停车。但是后来我们就是招都1个月，然后就才把那个地方分期。
我一进来就是所以我一直都拿来。
对，他这个感觉的意思。
对，我就是等到 TA 的时候认识，
好的，
他就会4点半突然到那种。干嘛？听了，做完记吗？我要听的抓到我，看然后再干嘛？不知道在。
对啊，为什么？ Oh yeah, it's about the deep store. Oh, I was there. Yeah.
bingo 和 Martin。
你是不是类似啊？因为他那个课他们的地方，我们班的70分直接上。
final 地狱
世界的话，我操！有检查在的那个。
更难，会怕比较难。
对的。
然后在然后就那个老师同事，他有个是 CS 的 speaker， 然后他叫去设讲，就是很水，但是就
晚上我
你现在为什么会找？
那个吗？哦，会加这个叫啥？
我也会。
英国老师3个，我
买了3个月，我看了。
完全没有一路没翻高票，
因为这是我这条广告就是他们的就自己买那个游戏，然后但是
这拿到了。
你真高兴说，然后我把这个不要我们回学校来北京，对，我好像对。
建议到赶快按下去。
好像有一些那个之前的，我也要找一找有特吧，我拍了个建设，但也不知道。
我想做啊，
会看不会看。那好像不对。他们好像很多，也没有什么人相对很好。4个人一起，
所以这也用了3分，所以你确定多少分？会多
才6口。
你是抽了吗？我还在纠结，我可能之后就要回去。
这个是相似，还有什么？
对，我当时好像就还蛮多的。
如果你偶尔等到了就全上完是吧？
就一般他的课业量还蛮大的，我下个学期然后我在家庭就
那我的意思就是找那个说，那种 grass，
然后还有什么？
就让他是这个感觉，你是什么左右？妈的，
哦，然后他好像那你后半就跟他说，然后你看我当时就是这些东西之类的，
没看到一个扫的，
那你刚才说你做过，
这全部人都有。
哎，
大家在底下打上一个
对，看嘛。
然后前后两个
不过那个结果是不好受，然后他说80%以上的就每个人就是1.5个，然后我也就是平时就是就是这种讲，讲的蛮幽默的。
哦，我蛮喜欢他，因为他
刷个人，
哦，这是有老外是不是？然后我不知道，但是我之前的全职老板我上课有点急，然后我就看那个东西，然后我就用英文说，因为上课最开始就是有点要这样死，就是然后网上哦对，我觉得就是从那个什么JavaScript，从那个开始。我感觉他的喜欢我才是
150
一开始，然后大概30秒交第一道题，然后
那个我感觉是
Novel 至少没那么多，还有 quiz，我觉得这个是 Novel 版的呀。
有的题搜不到。
当时那个讲没有，
那你这
能不能破趁你们一手？
对啊，我就这全起出来。
哦，你也是
我一个做了。
1.3门课。
改1-2个单词也不会了，比如说你把那个原题方你不会了，你改1-2个词，然后可能出套，改1-2个词。我看过是，
因为他只知道原题能够，因为他本质上就是在网上搜的案例。
咱可以上火联网。
还有quiz。
看不到球。
1-2个单词就差。他家的那个分析师。来的少。
那咱在一起。他说我还行，那你把那个教育做。
他是在纽约是吗？好少。
那我也12。
Another 5 minutes. This actually seems like a simple, quick the collab. So give me another 5 minutes and we can start up lecture after that, okay?
有那个 team 是吧？那里。哦，是要在 Teams 里面看吗？那边
Okay. Oh. All right. I'm going to try using the microphone. I feel like I'm shouting half the time. So yeah, let's go ahead and so I don't know, for those of you who've tried the collab, what did you think? Easy? There's actually going to be subsequent labs. I think every class will have a lab, and a lot of those labs are, I think, kind of very homework centric, right? So this one actually isn't specifically. The next lab might be, but this lab, in general, like your collabs will likely be very, very similar to what your homework will look like. It's actually a good way to get TA / my help on all of these. So let's go ahead and go to large scale data pipeline. So this is just an example of recommendation sciences. So here are some common components of a productionized system. This is actually, well, this is kind of a mix of a lot of people's productionized system. So in terms of distributed file systems, I think we haven't, I've kind of an answer and understanding that I think a lot of us are not familiar with what Hadoop is. There's also, I think these are just basically distributed file systems. There's Google file systems, Amazon simple storage systems. How many of you have heard of Amazon's S3? Yeah? Yeah, okay, great. Yeah, so I think, they're a special type of storage system, and the way they store it across all of their data is highly redundant, and you can actually use it fairly easily. Distributed storages and databases, there's like on those file systems, there's how you store the data. Logging events, I think when you get customer data, when you get search results, when you get, app data from users, for example, you want to log those. There's gathering data. So this is actually a real system, by the way. This is the system that we use here at Etsy, or where I work at Etsy. Creating training data. There's Apache Beam. Internally, Google calls it Flume. But there's kind of tooling that people typically use. We'll talk about Beam in lecture 3. There's a lab in lecture 3 focused on Beam. It's very easy. Offline training with an algorithm. That's kind of something we do after we've been able to create all of our training data from logging the events. So again, we have all these file systems, but then we log the events, get training data, do offline training. Right now, we still have some legacy systems. I'm not going to get too much into what we have. I think there's some agreements that I'm not supposed to divulge, but anyway, we do a lot of neural networks, which is again lectures 4 and 5, and subsequent, or actually it's 5 and 6. This is a little bit wrong. And then from all of that, we want to recommend people things. We want to recommend them listings, for example. And the way we would do that is with nearest neighbor algorithms. Finally, offline evaluation, replays. These are things that we want to make sure that the traffic is actually, sorry, you guys can't see it if I'm standing in front of it. We want to make sure that traffic is actually being served correctly. So we do offline evaluation and then replay it on the server, online model serving and ranking, and subsequently online metric monitoring. So I think I'm trying to think of a question that could be asked here. In terms of model serving and ranking and the metrics that we could monitor, what are some things that I think people typically monitor when you have an online system? Is there a lot of errors? Is the model performing differently than when we trained it offline? That's called model drift. These are things that we actually do measure in offline metric monitoring. We have dashboards of these. So there's that. And again, this is a recommendation stack at Etsy here. So we have users, or they can be using their phone, or they can be using the web. By the way, how many people use Etsy here? How many have used Etsy here? Good. Glad to hear it. Yeah, I think it's a great culture, a great place to work. So let's get back into it. You come to the site. There's things that you do on our site that those things get logged. And then you have a machine learning model that's supposed to provide recommendation, right? So once you log these things actually, we do offline training and then we deploy a model, right? So data gets captured from the app and the web into logs. And then that's robustly stored, distributed again across multiple different clusters and servers. Why? Because we have 200 million listings that are visited and viewed every single day. Every day, there's 200 million listings that people go to and click and look at. Right? They may click through a bunch of different ones, but yeah, it's quite a lot. Some of it's bot traffic, but I mean, the broad stroke of things is 200 million listings seen and viewed, and then subsequently logged, right? And so what do we do with these logs? And this is our training data. This is what it actually looks like, right? What's in their training? Visit logs, visit IDs. This is actually, so you come to the website and there's a visit ID, right? This is a visit ID, and this is a particular ID. Every time you come, there's a new one, right? And we obviously recycle them, but every time we come, there's a new one, and it gets captured as a session. And subsequently, you have a user ID. Every single one, if you actually are going to our site, you have a user ID. Better if you log in because that user ID is persistent. Persistent meaning you have it every single time you log in. So we have a lot of history for you to be able to personalize your recommendations, right? The update type, I don't remember what that one is. The interaction is what you actually saw, like what you actually did. An impression is, did you see listing A, B, C, or D, right? An impression is, did you see this particular listing? And these are the listings that you would look at. Listing, I mean like, oh, this is this particular product. So I want to buy product number 1. Do I want to buy product number 4, 5, or 10, for example, right? And finally, the timestamp. Now, for Etsy's business case, it's kind of fairly unique, but this is all the data that we have. This is all the data that well, it's not all. I mean, we have a lot of other data, but this is like an example of what we would need to train machine learning algorithms, right? So can anyone tell me what the label would be in this particular case? It's not immediately obvious, but it's kind of an interesting question. What would be the label? What could we use as a label? What would, for example, if I want to be able to buy something, what would we use as a label? Which column? Which column? Exactly. Interactions. These are the things that people actually do. These are the things that we care about, right? We care about whether someone bought something, whether or not they purchased it, right? We care about if they saw it. The impression is whether or not they saw this listing. If they saw it and didn't purchase it, that's probably a bad sign, right? That's probably a sign that we didn't give you the right recommendation, right? So the interaction is the label which we use for machine learning algorithms. And so everything else is what? What's everything else? What do we use those for?
Features.
Right, features. These are features. These are things that we have observed for each individual visit ID, for each individual visit, right? So this is training data. And which one of, oh yeah, so, okay. So again, you know, here's the implicit feedback. You have a user that comes to the site and you see the recommendation. Labels in this case are weak labels that are noisy, but in aggregate, the data can be mined to have general trends. What I mean by that is that like, hey, maybe I'm tired and I went to the website. And because I'm tired, I just browsed a lot of stuff. I didn't buy anything. So that's very weak, right? It's a very weak signal for us to use. But as you'll learn in later lectures, there's this law of large numbers that essentially says that in aggregate, if I train an algorithm with enough data with 200 million sessions per day or visits, interactions per day, if I train with enough data, then I don't know what that is. Then, sorry, if I train with enough data, then in aggregate, my model will be doing the right thing, no matter with all of that noise. And so this is why this is called implicit feedback. This is called implicit because we're not expressly telling the machine learning algorithm, hey, you should be, this is a good example. This is, you know, an example of a recommendation that is useful for somebody, right? Is that clear? Okay, good. So, wow. So at the end of the day, what we want to do, I'm not even sure, I didn't make these slides, but at the end of the day, what we want to do is we want to take user features. And for example, what could user features be? Okay, well, maybe I wanted to do that. Okay, what could user features be? They could be, you know, they're 20 years old. You know, where do they live? They spend on average how much money? And then here are all the recommendations they saw. And finally, here are some listing features that we want to match them up with, right? Okay, and we take all of this, we smash it into a machine learning model, and then that machine learning model tells me, oh, are you going to predict this? Are you going to go click on this? Are you going to go buy this? And so we're going to provide a recommendation. And then whether or not that recommendation is good or not, that machine learning model models that. It models those interactions based on the observations that you see, right? Based on the features that you see of, is it, I don't know, is it purchased a lot, or, you know, is it favorited or something like that? Based on that information, will you buy it or will you click on it? And so there's a lot of different stages to go into this. Again, I mentioned 200 million listings per day. Our inventory has, you know, a few hundred million listings as well. In terms of the different stages of inference, you know, how do we even like serve you recommendations real time? How does that even happen? Well, you can't do it like, hey, here's 200 million listings or 300 million listings. We can't just say like, oh, out of all these 300 million listings, here are the few that you should look at. Here are the few that we recommend. So we need to kind of prune it down. And the way we prune it down is the idea of these candidate sets. This is kind of broken down where you take your corpus and you look at you prune it down from 100 million listings down to maybe 100 listings. And then from those 100 listings, you do some online ranking, right? So online ranking is the real-time serving example, the real-time serving that we need to do in terms of machine learning that actually provides you the recommendations. That's done in, you know, a few hundred milliseconds, right? And then finally, there's a third pass ranking. Hey, maybe there's mature content. Maybe there's things that, you know, you don't want to see. And so you have things like filtering and heuristics and stuff like that. Things that, you know, you want to do after the machine learning provides you with the recommendation. Okay? And so again, I mentioned this issue of scale, right? And so there's a lot of different ways to store your data. Some of those data is actually easy or quickly retrieved, right? So the fast retrieval via perfect constructs like Bigtable or distributed key access key value stores, these are very low latency data sets, data structures, right? Or data stores. And so they're key value stores. And we'll learn a little bit more about this in lecture 2 and 3. But the idea is essentially, hey, what are some things that we can get our data really fast? I mentioned we want to rank really quickly, right? And then finally, machine learning model. I think I've kind of beat this a lot and beat this into your brains a lot today. Essentially, we have features and we have labels. And I think given all of the features that you have, you model it with the data. We'd use that for the ranking model. So once we've done that key value store, really quick lookup to get hundreds of listings, we do subsequently ranking on top of it with a machine learning model, right? We can do the key value store lookup with special machine learning algorithms offline in certain ways, but I'm not going to get into any of that. But the idea is the ranking side really needs to be a fast machine learning algorithm, right? And that's not always deep learning, right? Deep learning has millions of parameters sometimes. We don't want to do that all the time. It gets very expensive. And so model ranking, again, we take these features and take item features, and then we predict whether or not they'll click or, purchase or just look at it. And then there's many other applications. There's recommendation sciences, classification, and information mining, data generation. There's all these different applications. I'm not going to read through it. But the important thing to glean here is there's anything that you choose for your project, right? And so I think, with that, I think I'm going to kind of get into it. We're in the last mile here with our project. I'm going to talk about this in the next section. I think it's only been 20 minutes. Does anybody need a break? Should we do a break? Nope. Okay, so let's just go on into it. And so basically about your project is biggest part of your grade. It's 40% of your grade, right? So let's chat about it. We could talk about it in office hours. You have an idea, come to me, talk about it. Come to Christine, talk about it. Talk to our San Jose TA, TBD, whoever that would be. We want to make sure that we're helping to support you in terms of, an interesting thing that you can do data mining projects. By the way, like you do a data mining project, you put it on GitHub. That's something that people look at. You talk about, the projects that you've done in school. As a hiring manager, I also look at what type of, data mining project you do. So if you choose it, I don't want to say choose wisely, but yeah, it is kind of then up to you what you want to do. So it's open-ended, solve an interesting problem. There's no hard requirement except for the fact that it's 100,000 data points, right? You need to do some data mining, right? With this course, you can't just do you can't just do you can't just do a random project. And it can be a lot of mashup. So in terms of the data, it doesn't have to be one source of data, right? It can be a lot of data. So for example, there's Netflix data that's actually very popular. I have I think in preparation for this class, I was trying to look at data myself. I merged that I joined it. That's lecture 3. I joined it with IMDb data. Does anybody know what IMDb is? Okay, so yeah, good. So IMDb is a movie database. Join them too, and it's actually kind of interesting information if you run some NLP algorithms on it, right? So that's a really interesting project. You can choose whatever you want to do. If you need more guidance, email. Like if my office hours aren't enough, I know it's very late. Some of you might have classes back then at that time, so that's okay. We can schedule more time. I'm happy to help. I think our TAs are also happy to help too. And also, feel free to form teams and submit individually. I know there's been some questions about timeline for forming teams. You can just form them right now if you have an idea of who you want to work with. All I ask for that is you just let me know ahead of time who's in your team, so that if there's a mid-class or mid-semester shakeup, if someone needs a teammate or something like that, some people aren't getting along, God forbid, we can kind of go from there. So just let me know what your teams are ahead, once you form them, if you form them. And it's okay to do it by yourself. It's up to 4 people in particular team. Right? That's as large as I think I'm comfortable with. And beyond that, it actually becomes kind of more of a coordination nightmare. So yeah. I say 10 minutes per group, but it actually depends. So 40% of your grade write up and code and those types of things, right? 40% of your grade, 10% of that grade, I mentioned 25% of your project, 10% of your grade is your presentation. Depending on how many groups are formed, this time will change. And right now I'm saying 10 minutes. Might be my attention span just generally, but 10 minutes would be totally fine for now. But we can make it even longer if there are fewer groups. And typically time goes over anyway. So again, group, class project, real world data set, something useful, interesting and fun, multiple deliverables. And then again, we'll kind of iterate hopefully. Callable service we'll talk about. I don't think it's necessary. And then a final presentation and report. So I think like what might be useful is kind of some past projects. I didn't teach this class in the past, but here are some other projects that people did. This is, I thought it was kind of funny, is SquirrelNet. Is there a squirrel in this video or not? Am I detecting a squirrel? Can anybody see where the squirrel is actually? I'm trying to find it. Yeah, I think it's there. I'm actually the closest to it. So, yeah. But yeah, so is there a squirrel or not? That's kind of fun. Here's some other data sets that maybe, you know, COVID-19 there's a ton of data on that right now. Before there wasn't, like ironically, when we needed it. But that's out there. Airbnb, actually one of the most famous data sets or data sets actually, or people that provide open source data is OkCupid. Do you guys know what OkCupid is? It's a dating website. I think it's a lot of data because it's quite a lot of people are interested in it. Political science data. These are things that, elections are people in the United States elections do. Actually, one of the most, these are actually really interesting data sets that I looked up. Please feel free to find your own data. If you had, like what I was about to say is sports data. There are like a million people, like there's a lot of people like annotating, like looking at screens and annotating data, like sports, like NBA, like, oh, did this person make it? You're collecting a ton of analytics on the NBA or NFL. So like, if you're interested in sports, that's a good data set. It's just because people do this for fun for some reason. And then there's data sets from competitions in academia, common industry data sets. So here's a bunch of data. Sky's the limit, I think, for this. Any questions on anything so far in terms of your project? It's the first lecture, I know, but hopefully I'll come up with pretty interesting ones. Any questions on the range of projects that you could take on? What you could do? Like what you could possibly pick if there's something that you can't pick or you shouldn't pick? All right.
We find the data set from those resources and actually.
Well, you can from here, or you can find your own, I think, yeah.
If the database come from those sources.
Probably, yeah. Yeah. You might want to run it by me again. Like, sure, Kaggle is pretty reputable. But yeah, I don't foresee them doing anything with like, I don't know, mature content or anything like that. Yeah. Okay. So in summary, choose a topic that you're excited about. No idea? We'll help you. Okay, so now to today's homework. So did everybody get my team's message? I know some of you did. Okay, so that's the homework for this week. It's actually pretty easy. Your suggested reading this week is, massive mining data, MM and DS. I don't remember what the acronym stood for. So, my lectures are a little bit different than I think some other lectures that you might see. It is actually similar to Stanford in certain ways. So MMDS is taught by Yuri Leskovich at Stanford. And I also took lectures from Everaldo and some other people from Northeastern as well. However, I think it's kind of a good mix of all of those. And so this book covers a lot of it, but it won't be the only book. I'll provide you with good resources at the end of every lecture of what your reading should be for that week. You know, I think beyond that, I think your own, quite honestly, is, you know, when I was in school, there was no YouTube. And so I wasn't able to watch lectures online if I didn't understand anything in class. But right now there's a ton of resources, so feel free to kind of go to any of those. So anyways, homework this week is due next Wednesday, and it's not indicative of your future homeworks. This one is on Docker containers and so on. And it, I think, has kind of a base computer programming problem. The other ones, you can probably feel free to use Colab or Python notebooks. I wanted to give you this exposure. Well, so I'll tell you more about why I gave that assignment to you in a couple of slides. I think I got, did everybody receive my email? Okay, good. So how many of you use Git Classrooms before? So that's what we'll be using. So there's a link to the homework that I sent in the Teams chat. You just have to accept it. Once you've accepted, I'll see anything that you do to your repository, right? And, you know, I say Wednesday at 5 p.m. is your submission date or time, but quite honestly, like, it's probably like when we grade it, right? So you can actually change your repository until you grade it. Right? And I'm not encouraging you to be late on it. Quite honestly, I think it might kind of distract you from your next lecture and homework. Okay. So why this homework? So if you take a look at your homework, I don't know if you can see it right now. It's okay if you can, and don't need to open your computer if you need to do that. It's kind of focused on Docker. It's kind of a common delivery mechanism. We use Docker all the time, both, you know, containerization at Google, containerization at Etsy. I know people at Amazon, it's basically all Docker, right? And so the idea really is to use Docker environments and kind of just get used to it. You know, your project, quite frankly, probably would be best if you did use Docker, because I'm sure it's going to be kind of a larger code base, right? So that environment is something that will allow me and the TAs to be able to run your program if I don't have the same environment on my computer. So Docker is a way to package your code, right? There's a coding part to your homework. It's kind of a minor refresher for those of you who've taken CS5800. Still very relevant. And then an exercise to kind of bring your, I mean, we've all been on vacation for a little bit, and it's kind of a way to bring your brain back from the break. And the latter part of your homework is a bit more open-ended. It's kind of about design decisions. It's downloading the Netflix data. I think it's downloading the Netflix data set. I don't remember, I might have changed it, but I think it's downloading the Netflix data set and actually gaining some insights into it. So there's some questions that, you know, that have a little bit of design decision on your part on what you want to do with it. No right answer. You know, we just want to see how your mind works and what, you know, what you decide to do with the data, and also give you an idea that this is an open-ended class. This is an open-ended class that you can choose, and not necessarily a right answer for every single question. There might be a wrong answer. I mean, there might be something that's totally not what you're supposed to do, but certainly, like, there's no one right way to do things, right? So I think the reason why I'm assigning this homework, which, you know, I know in this class we talked about features and labels. We don't necessarily kind of have too much, you know, experience with a lot of things. So it is hopefully something like, oh, here's some data, why don't you play around with it? And maybe not getting into the machine learning or data mining side of things just yet, but it gives me a chance to kind of calibrate the homework, right? Is it too long? Is it too hard? You know, is it too easy? That's also a possibility too. How long did it take for you to do? And I want honest answers so that I can keep track of how long the homework, so how to do my next few homeworks, right? Did you have a question? Oh, sorry, just scratching, okay. And so with that, I think it's kind of pretty much the end of my class this week. I have this collab here, which I'll stay, you know, for you know, a little bit longer. This collab is very similar to your homework, right? So you can, or it's not a collab, it's actually a real lab. But this idea of running Jupyter notebooks or running something from your container is very similar to your homework. And so you might want to do it here just so that you have some experience with it, right? And so if you want to do that, we can do that right now. But before we get on to that, I think that's everything. Does anybody have any questions? I think we're kind of nearing the end of our night here. By the way, thank you for, I don't know like how, if anybody has eaten dinner or not. I haven't, like I had to rush from work. So I know this is not an opportune time for everybody. So thanks for joining this class. But back to questions. Anybody have any questions on homework or labs or lectures or materials? I'll try to make this material on the site online. Yeah. Is a lab part of the homework? This lab is not part of the homework. It's just something that will help you with your homework, right? Well, it won't help you with the homework. It's kind of almost your homework, like exactly your homework. The first part of it, at least. There's other parts of your homework. Again, if your homework is too hard or easy, just, those are also feedback to provide me as well. Any other questions? Yeah. I haven't yet. Will do. Yeah, but the lectures you guys should still have. And I think, where would you prefer me posting it? I can just send it out on Teams every week. On Canvas, yeah, okay. Yeah, I figured. Anything else? Okay. All right, let's go ahead and start on the data then. Again, there is some like participation, I think around class attendance and participation as part of the grade. So, I mean, it's good to try the labs just generally. But again, I'm not like grading anything regarding to the labs. It will help you out with your homework though. So San Francisco, any questions? All right. Okay, well, if there are any, I'm around for a little while longer.